Okay, good morning. So let us solve these four problems and then immediately go to the quiz. Okay, I hope that, so you see that these problems are chosen from level 3 problems in the book. So hopefully you can manage them. So we want to prove an identity. If you remember, I told you that it is usually better to start from this side, which is more complicated, and simplify so that we can reach to the other side. For example, here on the left-hand side, I have more complicated expression, so I would say the left-hand side is equal to, okay? For example, I don't know, you need to have a little bit of experience what to do. For example, I see that on the right-hand side, I have a mixture of sine and cosine. Here also, I have a mixture of sine and cosine, okay? So probably no clues from here, but I see that I have two fractions here, but here I have one fraction. So it motivates me probably to combine these two fractions. And if two fractions are supposed to be combined, if the denominators are the same, it is extremely simple. You just put the common denominator and add the numerators. But here we don't have that scenario. So what should we do? We have to make the denominators the same. So I have to start rescaling the fractions in a way that the denominators be the same. So how can I rescale that? Do you have any idea? So I would write cosine x, and then let me write something here. I have cosine x here plus sine x. So how should I rescale it? My goal is to make the denominators the same. So what do you take for rescaling? Yes? No, just read it for me. I just want you to see what is that I need to put here. Yes, thank you. So you multiply the denominator by this, and then you are not allowed to just multiply the denominator. You have to compensate for the change that you made. So if I ask you what I have written here, it will tell me that is an expression which is equal to this one. Yes, because that rescaling factor can be gone, and I will have this one. Okay, and then I rescale this in a way that the denominators become the same. So what can I do here now? So I can rescale the denominator of the second one. I hope that you know what to do now. So I take cosine x minus sine x, and then in the numerator I have sine x. So do you see that? How should I rescale it this time? Everyone? What should I write? Yes?
With plus and stuff.
Yes, cosine x plus sine x. If you are a little bit weak in that, so you need to sum up the previous videos in Math 3C that you are simplifying algebraic expressions, yes? But hopefully you know how to take the common denominator. Yes, so for example, in Math 3C you had this situation, a over a plus b plus b over a minus b, yes? If you have problems solving this problem, this is a Math 3C problem, yes? So take common denominator. But here that's the same problem, but the only difference is that cosine x is playing the role of a, sine x is playing the role of b. Yes? In this problem is exactly that problem. Okay? So that is what I'm doing here. So the good point here is that now I have the denominators the same, so I put the common denominator, and then I know that I have to add the exponent. Add the numerators. Okay. And now, at least it is good. Even though I have a very big fraction, but the good point, it is just one single fraction. And I have only one single fraction. So I would say this is a progress towards something positive. And the other thing is that hopefully you can recognize the pattern in the denominator, but don't multiply the denominator until the very end, okay? Because it might happen, because it is already in factorized form, It might happen that sometimes in the future something happens here so that you can cancel them out. So my recommendation is that don't be in hurry to multiply the denominator, but be in hurry to multiply and expand the numerator, okay? So I multiply this in, so this becomes cosine x to the power of 2. This becomes minus cosine x sine x, and then I multiply this in, plus sine x cosine x, and then finally sine times sine becomes sine x squared. Okay? And then hopefully you see what is happening, yes? This and that are exactly the same, but one of them is positive, one of them is negative, so they are completely cancelled. Yes? And then cosine x squared plus sine x squared hopefully is very familiar to you now. What's the answer? Just 1. So the numerator just becomes 1. And now that I am sure that there is nothing to cancel out, then I multiply these two. Of course, you know this pattern. Instead of multiplying 1 by 1, you know the pattern. It becomes the conjugate rule, yes? It becomes the first one squared minus the second one squared, yes? And if you see, that's exactly the right-hand side. So we started from the left-hand side. Little by little, we reach to the right-hand side, yes? So that is the solution to this problem. Any questions here? Okay. Now, hopefully, you know what to do with the next one, okay? So the next one, so 1 over 1 plus sine nu, this is just a Greek letter, it's like nu, okay? So if you want to add them, again, I see that I have only sine here, only cosine there. This doesn't help me that much because which combinations are famous in trigonometry? Not 1 minus sine. 1 minus sine squared is famous. Yes, so this is not something that I can do something about it. But at least I see that I have two fractions here, one fraction there. Again, probably the same motivation will motivate me to take the common denominator. So number 2, I start from the left-hand side again. Okay, I want to rescale the first fraction. So the first fraction has this as the denominator. Okay, can you tell me what should I do now? I have to rescale them and rescale the second one in a way that the denominators become the same at the very end. So what should I do now? Yes? Minus sine nu, yes? But when I multiply the denominator of this one by this, I have to compensate for my change by multiplying the numerator by the same factor again, yes? And I will do the same thing for the next one. Hopefully you know what to do. So I have 1 minus sine nu. If I want to rescale it, I multiply it by 1 plus sine nu. And then in the numerator, I have this one. Okay. Let me know if you have any questions so far. Is that understandable? Yes? Okay. So what we do now, the denominators are the same. So as I told you, don't be in a hurry to multiply. I think it will reveal itself in this example. Okay. So we take the common denominator. Oh, no, this is even very simple. So you just add the numerators, yes? And then you see that minus sine nu and sine nu are cancelled. So what is left for me, the numerator, is just 1. And then this is also a conjugate rule. So this becomes the first one squared, which is 1 minus sine. This is not 1, sorry. It is 1 plus 1, 2. And then this becomes this. But hopefully this combination looks familiar, yes? Either you have it in your memory or you just check it the formula sheet. But this combination should look familiar, okay? Otherwise you will have problems. But what is 1 minus sine squared, everyone? Cosine x. Yes, so that is 2 over, instead of this combination, I can write cosine nu to the power of 2, which is exactly equal to the right hand side. Yes? So these problems, I have just copied and pasted them from the book, and this is from the PDF file. I mean, that at this level is enough even for the national exam. Okay, of course, you should practice more, okay, a little bit, but this is at this level. So if you know what is going on, you are on the safe side. Okay, so for number 3, what is your suggestion? What is the natural step again? So here you have a mixture of sine and cosine, you have a cosine there. But because I do not have powers of 2, it is not a good idea to take sine off and write something in terms of cosine because it will include the square root sine. Okay? So that's not a good idea. So what is the next idea? Again, I have 2 fractions here, 1 fraction there. So that's the same strategy, yes? So I take the common denominator. Okay, but left-hand side is equal to. What is the common denominator here? I have to rescale the first one, but can you tell me by which factor? Which factor? What? Cosine, yes? I take cosine here, so I have to rescale the numerator as well. Yes? So I multiply the denominators. Is that clear for everyone why I'm doing this? If you have a little bit weakness in this, I will try to find some videos from Math 3C. So you need to work a little bit about addition and subtraction of rational expressions, the first chapter of Math 3C. Okay. I'm also teaching it right now, but I'm not publishing it on YouTube. If you are interested, you can send me an email. I can send you the links. Okay. I haven't put them on the YouTube. So here I have this, and then the next one. How should I rescale the next one? So cosine alpha is already there. My goal is to have the denominator as before. Okay, so what is the rescaling factor now? Everyone else, yes? 1 plus. Are you sleepy or not? What? Yes? 1 plus sine alpha. Then what happens? Then you take the numerator here, which was the old numerator, but you need to multiply it by this rescaling factor. Are you happy? Yes? Do you know what's going on now? Yes? Okay, but now what happens? These 2 expressions are exactly the same, so it doesn't matter in which order I multiply. So let me keep them. As I told you, as an advice, don't be in a hurry to start multiplying the denominator, but be in a hurry to multiply the numerators. So cosine alpha is what? Cosine alpha squared. 1 plus sine alpha times 1 plus sine alpha is 1 plus sine alpha squared. Yes? Okay, then what? Yes?
You can rewrite cosine alpha squared as 1 plus sine alpha times 1 minus sine alpha.
Yes, that's a very advanced way of doing it, but let us not do it. Okay, let us take the natural step. The natural step for me is to open up the numerator. Okay, so this is very simple and working most of the time. Okay, so this to the power of 2, I raise it to power 2. This is the first one to the power of 2, which is 1. 2 times the first one times the second one. It is 2 sine alpha, and the second one squared is sine alpha squared. This is the natural step to do. What you said is also working. I saw it. But let us just follow the most natural way. So the idea is to take the common denominator. After that, don't multiply the denominator. Simplify. Simplify means expand. Open all the pair of brackets and simplify as much as possible. Okay? And I hope that everyone agrees that this is the correct one. It's still, if you write 1 and sine alpha squared, missing this term, you will be in trouble. So make sure that you really understand what's going on. Okay, what else? I have 1 plus sine alpha, and I have cosine alpha. So what do you have for me in the numerator? There is one very famous combination that appears in the numerator. Yes, what is that combination? Cosine alpha squared plus sine the same angle squared. So this one plus that one is 1. Yes? And there is another 1 here, so it becomes 2. Yes? So this becomes 2 plus 2 sine alpha. What is the next step, do you think? What is the next step? Yes?
Open the brackets a little.
No, it doesn't. It's not good. I told you, don't open it up, okay? Unless you're sure that there's nothing else can be done. Yes?
Factorize 2.
Factor 2, okay? So factor 2, and then it becomes 1 plus sine alpha. The reason that this is better, because then you see that this factor appears that can be cancelled out, yes? Now this factor and that factor are gone, so this becomes just 2 over cosine alpha, and that's exactly equal to your right hand side. Yes, so that's why I'm saying if we have multiplied this before, then we didn't see this. So you need to keep it until the very last step. If needed, then multiply. But here you see that it was not good if I have multiplied this before, because I couldn't see that this and that will be cancelled. Okay, so don't do that. And finally, the last one. So for the last one, what is your suggestion for me? So I hope that you agree. Again, I start from the left-hand side because it is more complicated. Okay, but what should I do now? Yes?
Turn cosine x squared to sine x squared divided by
Cosine squared. Yes, one motivation is that you don't see any tangents on the right-hand side. So it means that you have to get rid of tangent. But there is one formula for us to get rid of tangent, and that is the meaning of the tangent. So that is good. So, but I have a fraction line here. Instead of the numerator, I hope that everyone agrees that I can write sine x to the power of 2 divided by cosine x to the power of 2. And then the denominator the same. So I have sine x to the power of 2 cosine x to the power of 2 plus 1. So if I want to compare it with Math 1C problem, Math 3C problem, this is something like this. So you have also exercises like this in Math 3C. So in principle, you should be able to solve that. So what is your suggestion for me to continue?
multiply both sides with cosine squared.
Not both sides, the up and down.
Oh.
Yes, yes. Yes, you are right. So I rescale that. This is a very good way of calculating. For example, if I want to calculate 1 over 2 plus 1 over 3 divided by 1 over 2 minus 1 over 3, one simple way is, of course, to take the common denominator 6, and then this is 3 plus 2, and then common denominator 6, and then it becomes 3 minus 2, and then it becomes 5 over 6, and then it becomes, I don't know, 1 over 6, and then simplify it becomes 5. But another method is to rescale the numerator and denominator so that I can get rid of these partial fractions, because that's a fraction in fraction, yes? So what I do, I multiply the numerator by 6, this becomes 3, this becomes 2, multiply the same thing by 6, this becomes 3, this becomes 2, and then you see that you get 5. So this is faster way of doing the same thing. So I will do the same thing here, as you said, but you need to write it down. So what you said, you multiply the numerator by this factor. Yes? And you also have to multiply the whole denominator, not just one part, the whole denominator by the same factor, because you're not allowed to change anything. By rescaling, I'm not changing the fraction. Yes? But why this is good? Because the cosine x squared that I multiplied in the numerator will cancel this partial fraction. And what is left for me is just sine x squared. Okay? And now here, I have to multiply it here. I have to also multiply it there. But if I multiply it here, you see that again the same thing happens. Cosines are cancelled, sine x squared is left. Yes? And if I multiply cosine x squared by the next term, that is 1 times this, which is just cosine x squared. And again, a famous identity appears in the denominator, yes? So what is the denominator now? 1, and any number divided by 1 is the number itself. And that's exactly equal to the right-hand side. Yes? So we will, little by little, we will solve a little bit more problems on this topic, because this is something that you have to practice to master, but it is not hard that much. If you have a little bit of problems in common denominators and simplifying expressions like that, then we have to find a way to fix it, yes? Because then most part of it is not the new lesson. Most of the things that I am doing, common denominators and things, are the previous lesson, okay? The Math 3C lesson. Okay, any questions? Okay. So we stop here so that we can start the quiz, okay?